For decades, the theory of a space station that gathered solar power and sent it to the Earth, which had been published by the science fiction writer Isaac Asimov in 1941, had been considered as a fantasy. But the constantly increasing power demand and the issue of climate change have pushed the scientists to think about every possible idea in order to get a clean and sustainable energy, even if the idea looks like a science fiction. Well, recently this idea started to have acceptance from scientists and entrepreneurs, since the technology has been developed in a very fast way. In this video we will talk about space-based solar power system. So welcome to Game Changer Tech. The climate change is the greatest challenge of our time, so there is a lot at stake. From rising global temperature to shifting weather patterns, the impact of climate change are already being felt around the globe. Overcoming this challenge will require a radical change in how we generate and consume energy. Renewable energy have been developed in a very radical way in the recent years, in terms of efficiency and lower cost. But they didn't provide a constant supply of energy. Wind farms only produce energy when the wind is blowing, and solar farms only produce energy when the sun is shining. But the fact is, we need energy around the clock and every day. Well, space-based solar power system, or SBSP, would be generating solar power in the space and transmit it to the Earth. Now, there's two main advantages of this. Firstly, the station could orbit to face the sun 24 hours a day. And secondly, since the Earth's atmosphere reflects and absorbs some of the sunlight, so the solar cell above the atmosphere would receive more sunlight and produce more energy. Now, the optimum solution is to use a huge mirror, like solar reflectors, installed on satellites in orbit, which will concentrate energy from the sun onto solar panels. These in turn turn the energy into electromagnetic radiation, which is beamed back to the Earth in either laser or microwave form by an antenna. Finally, rectifying antenna on the ground collects the waves or radiation from lasers and converts them back into electricity to be distributed to the grid. Actually, in the 1960s, the scientists noticed satellites in the high orbit that kept pace with the Earth rotation spend almost no time in the Earth's shadow, and they call it geostationary orbit, which would be the best place for the space-based solar power system. Now, for the space-based solar power system, there are two options. The first option is to put the satellite in the geostationary orbit, which is 36,000 kilometers above the surface of the Earth, with extremely high microwave pointing beam. This method can supply several gigawatts of power, but the satellite has to have a huge antenna and massive mirror. According to some studies, they weigh above 80,000 tons with a mirror of 3 km diameter. Fortunately, the second option is more applicable, which consists of using many small laser power satellites in the low orbit of Earth, around 400 km above the surface of Earth. Now, both methods does have pros and cons. The pros for microwave satellite method are enormous amount of power that could reach up to several gigawatts of power, and this amount of power is enough to supply a big city with energy. And the bad weather, such as clouds and storms, would not reduce the transmitted energy. While the cons are, since the microwave has to travel for a very long distance, the beam would spread significantly, which means that the receiver on the ground would have to be several kilometers across to intercept it. Also, it is very difficult to launch and construct this massive system in the space. On the other hand, laser power satellite has many pros, such as easy to deal with the small size satellite, and since the laser power is very concentrated, the receiver on the ground would be a small area of a few meters. Now, the cons for laser power satellites are lower delivered power of a few megawatts, and the bad weather could reflect the laser light, which reduce the received power on Earth. So this technology has several advantages over normal solar power. Firstly, it eliminates the downtime due to the bad weather and nighttime. In an average winter month in Europe, only 3% of sunlight reaches the surface of Earth, while a satellite in the space could gather the energy of 99% of the year. And secondly, it bypasses the problem of energy storage, as a continuous stream of power from the sun will allow the energy to be beamed down directly when needed. Finally, the light in the space is unfiltered by the Earth's atmosphere, so it's much stronger. For these reasons, and according to Energy Match Service Green Match, the SBSP could generate 40 times more energy in compare with the Earth-based solar power. Despite its many advantages, there is one major drawback to this alternative source of energy: the astronomical cost. While in theory, the technologies needed to make SBSP a reality already exist, the cost of production, launch and assembly, which would most likely have to happen in space, currently makes it commercially unviable. Currently, the key players in SBSP include Chinese, US and Japanese governments, which are all eager to secure access to a clean and unlimited power sources. Chinese, for example, is planning of sending the first functioning prototype into space by 2022, with intentions of making SBSP commercially viable by 2050. SBSP could be the route to ensure Earth energy needs are met in the long term. The first country to achieve it will gain geopolitical and commercial advantages. That arguably could be even a better story than Bond movies. Thank you for watching this video, and I'll see you in the next one.